Hi everybody. In this video we are going to take a look at the use random source function. So we are going to explore a little bit of what it is, some different arguments we can pass into it and how that will affect its output, and then look at ways that we can apply those outputs in musical situations here in Sonic Pi. So to bring it up in the docs, use random source is going to change how random numbers are chosen. Now, if you're not familiar with how randomness works in Sonic Pi, I did make a tutorial which kind of gets into more of how random numbers are generated in Sonic Pi, and then looking at the idea of true randomness versus pseudo randomness, and in that I get much more into the use random seed function, which has a lot to do with sort of how the random number outputs are going to be. But the use random source is going to affect how those random numbers are chosen in terms of what the output will be. So if we look here, the different arguments that we can pass are white, pink, light pink, dark pink, and Perlin. And these are in reference to types of noise outputs. So to sort of give us a better idea of what this is, I have a P5JS sketch set up with sort of arrays of outputs that we get as the result of passing different arguments, parameters into the use random source code. So we have the white, the pink, the Perlin, light pink, and dark pink. And just to let you understand kind of how that happens. So start with use random source, and then let's say I pass it white, which is the default. So if we don't actually call this use random source function, the default source of random number generation is going to be white noise. And then what I did was I made an array, just a blank array, and then 200 dot times do, so I made it that block. I then created a variable that would store the output of rand. Rand is just a random number generator that will randomly output a number between 0 and 1, so a floating point decimal number between 0 and 1. And so that's going to happen 200 times. It's just going to, every time through this loop, it's going to generate a random number and store it in n. And then what I do is I'm going to push that value into my A array. So when it's all finished, I'll have an array that has 200 values in it, all randomly generated numbers between 0 and 1. And then I'm going to put A here. So if I run this, see, the output I get is this long array, and all just has a bunch of random numbers between 0 and 1. So what we can do here is I'm going to sort of visualize the output so we can kind of see how it scatters across. And I mean, if you're not familiar with P5JS, it's just a visual language, a web-based version of processing that uses JavaScript. But essentially what I'm doing is I'm passing all these values and I'm mapping them to the size of the canvas. So a number that is 0 would be at the top of the canvas. A number that value is 1 would be at the bottom of the canvas. I'm sorry, I believe it's vice versa. The 0 would be at the bottom and 1 would be at the top. Either or, it doesn't. That's not really the big issue or the thing to worry about. So if I press play, and just to be clear, I'm going to uncomment white. So I have an array called A, and this is the white noise output. And if we look, we see it's scattered all over the place. So there's some at the top, there's some at the bottom. It's all over the middle. So white noise is just kind of pure randomness. There's no real rhyme or reason to it. It's just going to be all over the place. So if I comment that out, and I'll sort of go by the docs here as well. So white is totally random between 0 and 1, even spread across values between 0 and 1. Now pink is more likely to produce values in the middle of the range and less likely to produce at the extreme. So between 0 and 1, we can expect to see a concentration of values of 0.5. So if we go to our visualization here, we get rid of this. So now I'm passing the array of pink, so which I got by just changing this to pink, creating a new array, and then took this array and passed it into P5. If we press play here, you can see now we don't have really any dots at the top or the bottom, which would be values closer to 0 and 1. We see mostly them spread within the middle here. So, and if we kind of just glance at all these values, we see a lot of 0.5, 0.4, couple 0.3s, but it's definitely distributed more equally in the middle. Okay, so next we'll take a look at Perlin noise. So Perlin noise is a special kind of noise which produces gradients, so less likely to have large jumps, and we'll see kind of smooth motion going up and down. So I'm not going to get into what exactly Perlin noise is, but the idea is that whatever value kind of comes next is going to be closely related to the value that came before it. So you're not really going to get big jumps. You're kind of see it might go up and up and up, and then it might go down and down and then up and down, but you're not going to see a big spread from one way to the other, right? So if we press here, so we see the values go up and then down and then up and then down and then up, and so they kind of maintain a certain direction for a while, and then they might change a little bit, but each value that happens is going to be kind of directly connected to what came before it. So that's Perlin noise. Next we have light pink, which is halfway between white noise and pink noise, so a bit more random and jumpy. So if we now uncomment this is our light pink array of values from Sonic Pi. This one a little more spread out, still not seeing much in 1 or 0, but a little bit more of a range than we saw with just the regular pink. And then finally we have dark pink, which is halfway between pink noise and brown noise, which brown noise isn't an option here with the use random source, but just so we can go and see that distribution here in P5. This we see is much more kind of linear, and everything seems to just kind of follow the same trajectory. Not a lot of spread out here. All right, so that gives you a good visual kind of understanding of the types of values you're going to get if you use any of these random sources for random number generation. Now, how can we apply these random sources in musical ways in Sonic Pi? So one of the sort of common things, and I've done a tutorial about this, was random melody generation. Now, usually I would use white noise for that, and the reason being is that if we were to say do like Perlin noise, which, you know, looking at the actual distribution of that, if we go back here for a second, kind of look at that, you would think this would give us an interesting sort of melody. There's ups and downs, there's contour to it, we're kind of moving in different directions. So seemingly this could create some interesting melodic patterns. But the issue is that if I create a live loop and I'm going to do like play, scale, let's do just like C4, I'm just going to do a major scale, and I'm going to do dot choose, and then sleep for 0.5. Okay, and I'll move this into our live loop here. So the issue is going to be, well, you can listen in here. So what we're getting is, keeping in mind that this is just an 8-note scale. And so we wind up just getting the same notes over and over and over and over and over again. And musically, that is not super interesting, and not the kind of melodic quality I would want if I was going to be randomly generating that. So again, if I were to switch this to white, there's more jumps, there's more changes in notes, there's more sort of interesting kind of harmonic things going on as we go through that melody. Now, certainly there's some bigger jumps. I've done a tutorial also about a way you can kind of smooth out so there aren't as many large jumps by using conditional statements and stuff like that. So you can check that out if you want to find a way to kind of smooth out what you're doing. But I would not say like Perlin noise or pink noise or any of those random sources are really going to generate some interesting melodic qualities, okay? However, they might make, if you're looking to kind of keep more consistent notes, then that might be what you're going for. So for example, I'm going to take this down and actually change this to minor pentatonic and go back to Perlin for a second here and make like a bass line. I'm also going to use synth here, the tech saw. So I could have like a bass line maybe and use Perlin noise to that effect. So another interesting way to use Perlin noise, I think, is if we use, I'm actually going to do this below, use synth defaults, and I'm going to make a cutoff here. And I'll do a random between, say, between like 60 and 120. So this will kind of move and automate the change in the cutoff so that it's not going to be random in the sense of just kind of all over the place, but think of it almost in terms of like turning a dial in one direction and then another direction. And that can create some interesting effects as well if we're using the Perlin source for our random output. So let's hear what that sounds like. So that, I think, is a more interesting use of Perlin as a random source, in that you sort of are kind of moving up and down through something like a cutoff. So you sort of can kind of highlight the different effects you get from that without it being kind of all over the place, and you sort of are gradually moving through certain values to get different effects from that. So I'm going to just kind of keep building off of this and adding some different sources here. So here I'm going to use random source, and this one I'm going to use pink noise. Remember, pink noise was going to give me mostly values kind of in the middle, 0.5 and such. So for this, what I think is interesting is if we use maybe like a hi-hat sound. Let's say like gem maybe, and we use it for the amplitude. And if I just do rand here, it's going to again kind of give me, to go back to the visual for a second, it's going to give me a lot of values. Oh, I forgot to comment this out. A lot of values sort of in the middle, so like 0.5 kind of. And this will also give me a bit more of like a realistic kind of sound, as if like a human was playing it, because the human's not going to hit the exact same force every time to give the same amplitude. And in this case, maybe just make it a ring like 2 tick through that. So this will give me, actually before I do, I'm going to sort of comment this out so we can hear. So it's going to be a fairly consistent amplitude, but it's going to change slightly, give it a little more sort of realism to it. So that's one way I could use this pink noise. I'll kind of bring these all together at the end here. So I'm going to make a live loop here. In this one, I'm going to use a random source. I'm going to use dark pink, which, or was it? I think it was light pink I wanted to do. It's the one halfway between. So I still wanted to be a little more random. And in this one, what I'm going to do, I'm going to use it for amplitude again. I'm going to do sort of a sample house here. And I'm going to do rand for this, and then sleep 0.25. And then I'm going to sample and just do a regular bass drum at a consistent amplitude, maybe like probably just 1.1, and then sleep for 0. So this one's going to do kind of a bump, 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 but it's going to change the amplitude of the first one more randomly with this light pink distribution, and then consistent same amplitude for that. So sort of building up to this more emphasized kick drum here. All right. So why don't we put those together? I'm going to sync these all to this A loop here. Sync this to the A loop and this, and then if we put these together. So all these different random sources sort of doing their thing to just give it a little bit more, what have you. So one more thing I'll do here is I'm going to kind of go back to a more traditional use. And I don't necessarily need to write this as it's the default, but just to kind of emphasize this, I'll use white noise here. And I'm going to use the synth of like chip lead. And here I'm going to play a scale of, we'll go C4. I'm just going to do a minor scale. I'm going to add a couple octaves to this. We're going to do dot choose, and then we're going to sleep for 0.5. So this now is just going to give me kind of random distribution, completely random, up and down with that over this 2-octave span. So there'll be big jumps, there'll be small jumps, but if we put it all together, so I like that. I mean, there's certainly quite a bit I could do with that, but for just a sort of small idea. So again, just kind of break it down. In this first loop, we have purlin noise, which is giving us sort of gradual ups and downs, which is affecting the cutoff of the synth, but also it's affecting the notes that are being chosen here from this minor pentatonic scale, but I'm getting a lot of sort of repetitive notes, and then it'll shift to another note and hang out there for a little while. In this loop here, we we have the hi-hat, which is using pink noise, which is going to be more evenly distributed towards the middle, and that's affecting the amplitude to give it a more sort of realistic kind of sound. Something similar here with the light pink in the kick drum, and just sort of giving a more random amplitude to the first of two kicks, and this kick more consistent. Again, that also gives kind of a bit more realism to it. And then finally, this last one, just using the traditional white noise to randomly choose notes out of this 2-octave scale to give a bit more melodic quality to it. So those are just some suggestions and examples of how you can use different random sources for output in your loops and music in Sonic Pi. There's certainly plenty of other ways you can do, so I recommend you kind of experiment with each one and see what you can come up with. But hopefully this gives you a bit more insight into how the output works and what you can do with it.